Hey everybody, welcome back to Environmental Science Analysis with Dr. Lisa. Today I'm going to talk to you a little bit about data structure, and in the process I'm going to show you how to make a stacked bar graph. So when you download data, typically you're downloading from something like Storette, or you might be looking at a database. Usually what you have is what is known in the business as long data. So here's an example. This is the new CARP database, and this just happens to be the table on invertebrates. So this is where they measured chemicals in invertebrates. These are primarily Nereis virens. These are worms that they're used for the 28-day bioaccumulation test. Not that you need to know that. Okay, so and you notice that here over on the right here is the actual result of the measurement. So these are different chemicals, parylene, naphthalenes, fluorine, all of these things measured. Here's the result. And it's one result per row of data, right? So every row in here is really just one result. And for that reason, you end up having the same sample in here many, many times. So like all of these things right here represent the same sample, but it was different chemicals measured within that sample. Different, in this case, different PAH compounds measured in that sample. So that's what you would call long-form data. And of course, it's long-form data because, look, it's 88,000 data points down here, 88,831 data points. So it makes it a very long table. And sometimes that's not what you want. So in my class, I've taught you how to do a crosstab query. So here's a crosstab query from that table right over here. I'm doing a crosstab query. I'm looking for dioxinfuran surrogates, and then if I go look at the data sheet that comes out of this, now this is what we would call a wide form data set. So each sample on here is one row, and there's multiple chemicals. Each of these columns is one chemical that was measured in this sample. So there's many rows, many columns of data associated with this one sample. But as a result, now this thing is only 249 rows long. And of course, we've lost a lot of data in the process. Lots and lots and lots of stuff has gone missing here. But it's what we would call wider form data, because it's still pretty long, but it's not nearly as long. And so it's what we would call a wide form of your data. So this wide form is what you and I are most used to thinking of as a table of numbers, right? That's what you and I usually think of when we think of a table of numbers. And so intuitively, this makes a lot of sense to us, and it might make, in some ways make it easier for you to do your data analysis. But once you really get into the data and a little bit more data mining, you realize that the long form of data is actually very powerful because it retains all of the information. And there are a couple of other reasons why long form data is nice too. So when you're working with data, it would be nice to be able to convert back and forth between long and short form using R, which is what we're going to do now. So I have turned the black background on my R to this dark blue color. I like it. It's much easier on my eyes. I'm an old woman, and I have a hard time with my eyes, so I like the blue background. So this is the data set on Lower Duwamish waterway tissue that was included in some of the other packages that I've, videos and other resources that I've posted on the website. So we're going to use this, and I'm going to read in my data. So this is Lower Duwamish waterway tissue. So here's my data, and you can see that this is in square form, or wide form. Okay, so I've got the index, study code, location, sample code, species, tissue. What type of tissue? Is it the whole body, edible meat? Class, is it fish or shellfish or benthic organisms? Latitude, longitude, and then you can think of these as just concentrations of chemicals. They're actually outputs from the PMF model, but that's not important. Just think of these as concentrations of chemicals. And here they're expressed as a concentration, and over here they're expressed as a percent of total. So it's wide form. One row on here represents one sample, and within that sample there are many different characteristics that have been measured here, different tissue concentrations. So I wanted to do something very simple, which was to just create a stacked bar graph. And it took me like 2 days to figure out how to do this. So now I'm going to skip forward to the part where I know how to do it and show you. And it involves reshaping the data. So here, there's some other stuff in this file, but we're going to go down here to where we make a stacked bar chart. And the first thing I'm going to do is select only the required columns out of my data frame because it's just complicated. And if you're going to be moving your data from long form to short form, it helps if you don't have all that extra crap in there. So I'm going to create a new data frame. DF is just sort of the default that people like to call their data frames, but again, you could call it Fred or Nancy or whatever you want. I'm going to call it df underscore factors. Okay, and this is going to be, I'm using my little arrow command, I'm feeding into that a subset of some of the data from this thing called lower Duwamish water tissue, and I'm selecting here columns of data, and I'm selecting columns 5, 7, 10, 11, 12, 13, 14. Okay, so run that, and then here's my new data frame called factors. I can look at this. And so it's just a pared down version. I've got the species, the class, and the concentrations of these 5 chemicals. So now, let's say I want to reshape it from this wide format into a long format, which it turns out, at least I couldn't figure out how to make a stacked bar graph without doing this. Perhaps you can. You're smarter than me. So to do that, I'm going to use this package called tidyr. Okay, so I'm going to run that. Excuse me. Control Enter. And so I'm going to create this thing that I call data long because I'm taking my wide data and putting it into a long format. And so I'm going to feed into this new thing I'm creating something that comes out of the thing called df factors, but now I'm going to use this command pivot longer, pivot underscore longer. There are other commands. You can use melt and gather and some other things, but this pivot longer is sort of the new way of doing this. If you go over here to the help command and you type melt, which is one of the ways of doing this. Sorry, that's not what I wanted. Try gather. Notice that here it says life cycle retired. And then it says development on gather is complete, and for new code we recommend switching to pivot longer. So that's why, you know, if you Google how to do this, which is how I do everything, right? I just Google it and try to figure out how from the Googling. You will pull up a lot of videos and code snippets and stuff that might use this command gather, but you know, they're telling us that now we should change over to pivot underscore longer. And then, of course, if you want to go the other direction, you can do pivot. There we go. No, I can type pivot wider. See, so there's pivot longer, and then there's pivot wider if you want to go the other direction, if you have long form data and you want to make it into a table. So pivot wider is sort of like doing a crosstab query, but you're doing it in R. Brain explodes, right? So if I want to find information on pivot longer, I can go here, and it will explain to me a little bit about the syntax. So basically, the first thing you do is you put in the data, right? So the data here is going to be this thing called df factors. And then the next thing is which columns do you want to consolidate into one column? And for me, it's columns 1, 2, 3, 4, 5, 6, 7. I want all of these tissue columns to collapse into one column. So that's why I'm saying collapse here, columns 3 through 7. And the names of this new column that I'm going to create when I meld all these together, I'm going to call it, you can call it anything you want, I'm going to call it factor. And then the values that are going to be created when I do this, I'm calling concentration, conc for concentration. So when I run that, hopefully that'll make a little bit more sense. So here's the data long, I can open it up. And now notice I've created this thing, and I have tissue 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So they're all in here. All the tissues are now designated as whether they're 1 through 5, and all the concentrations are now in one column of data. And it's long, you know. That's why they call it pivot longer. Okay, so now I have my data in the right format. And I'm doing this because I wanted to create a stacked bar chart, something that would have taken me literally 2 seconds in Excel, but took me 2 days in R. But now I know how to do it, so I'm feeling better. So I'm going to take this thing called data long, and I'm going to use my little pipe operator and feed it into ggplot, which I'm going to use as my plot engine. And then this stands for aesthetic. I don't know why. But the X is going to be the species. So if I look back at the data, that is one of my terms here, species. So my X is going to be species. The Y is going to be this thing that ended up in value, which I have called, this is going to be, that is going to be species. Yeah, so I do have these right. Sorry. Data long, I'm feeding into ggplot, which I'm going to use to plot things. Aesthetic, I set x is equal to species. The y is the value. Sorry, moving things around. Y is value. The fill, I'm going to make a variable. This fill equals variable is what's going to make it pretty colors. And then this basically just generates a plot of some sort. But then when you add geometry column here, geom_col, this is what's going to make it a stacked bar graph. And by putting position equals stack, the bars will be stacked on top of each other. So control enter. And well, look, I did it. I'm so proud. So these are the different species on the x-axis. This is the concentration on the y. And you're stacking up the 5 factors that can contribute to each of these concentrations of chemicals in the fish. Okay, so very proud. This took me, like I said, about 2 days. And you notice that the names here, because they are written horizontally, they're kind of tough to see. So what I can do, one of the ways that you make changes to lots of functions, but in particular to graphs here, is you can use exactly the same function. So this line of code is exactly the same as the one above here. It's just that I'm adding a little plus sign on the end, and now I'm adding theme axis text equals element text angle 90. So what I'm doing here is I'm just shifting this text and rotating it 90 degrees so that you can, booyah, you can actually read the species names here, making it a little bit easier. So yeah, that's how you do it. You transform things from long to short, and you can do a stacked bar graph. If here, instead of geom_col, I put geom_bar, if you see how if I hover over this, it says, I hover over this, it says there are 2 types of bar charts, geom_bar and geom_col. Geom_bar makes the height of the bar proportional to the number of cases in each group, or you can weight them. If you want the heights of the bars to represent values in the data, use geom_col instead. Took me like 48 hours to figure that out. But anyway, so that's why we're using geom_col. And again, when you start to type stuff here, you can also kind of look at all of the other options and see what's possible, and scroll over them, and information will pop up. Okay, so that's how you make a stacked bar graph and how you move things from long to wide format.